Let's talk about exponential functions. What is an exponential function? We hear things like this all the time. Well, that exploded exponentially. But an exponential function is just a function of the form y equals a b to the x. Now, we're calling it exponential because the exponent is where the x is, instead of x being down here at the base. Now, this a is our initial condition. Now, why do we call it this? Well, when x is 0, that's usually initial. Then y is a, b to the 0. Oh, now you remember, anything to the 0 is 1. Now, if b is greater than 1, then this is going to show exponential growth, where if b is between 0 and 1, we're going to get decay. I want to point out that b must be positive. We never deal with b being negative. It doesn't make any sense mathematically. So let's look at two different cases of exponential growth. The blue curve is y equals 2 to the x. Let's look at a couple of points. All right. When x is, let's see, negative 2, what is y? Y is 2 to the negative 2, which is 1 over 2 squared, which is 1/4, or 0.25. And you see that's very close down here to the x-axis. When x is negative 1, y is 2 to the negative 1, or 1/2, 0.5. And I was able to graph that point right there. Right there. When x is 0, y is 2 to the 0, which is 1. When x is 1, y is 2 to the first power, or 2. When x is 2, y is 2 squared, or 4. So you see here I've graphed this y is 2x, and in this example it's blue. Let me switch pen colors, and I will graph y is equal to 10 to the x. Let's see how these two curves differ. Let me just start by doing a few points. When x is negative 2, y is 10 to the negative 2, which is 1 over 100. Ooh, so that's very, very small. When x is negative 1, y is 10 to the negative 1, or 0.1. You can see that's very close to the x-axis again. When x is 0, y is 10 to the 0, which is 1. When x is 1, y is 10 to the first power, or 10. You can see this is going to get very large very fast. When x is 2, y is 10 squared, or 100. And that's well off my scale. So you see how the base changes this exponential function. The larger the base, the faster you're going to have this uncontrolled growth, we call it. However, I want to point out that all exponential functions, y equals b to the x, no matter what your base is, goes through this point right here, 0, 1. And then they have a horizontal asymptote at y is equal to 0. It becomes unbounded in one direction, but when you go, in this case, in the negative direction, it becomes infinitely close to this x-axis. The domain of any exponential function is all reals, and the range with no modifications here is y greater than 0. It will never actually include y equals 0. So let's look at these examples and see if we have exponential growth or decay. Now, I don't care what that number right there is. To determine if it's growth or decay, I look at the number raised to the power. Since this is less than 1, I have decay. Exponential. What's the y-intercept? The y-intercept is when x is 0, y is 12. So there's my initial value. For this problem, I have 2 raised to the x. So because 2 is greater than 1, this is exponential growth. The y-intercept, when x is 0, y is 0.25. What if I have a word problem? Suppose you put $1,000 into a college savings account for 4 years. The account pays 5% interest. All right, this is going to be exponential growth because you're adding every year.